Hello everyone, and welcome again to our Green IC research group at NUS. We are very excited to present our recent work on the first Wi-Fi transmitter with power consumption below the 1 microwatt. Now, our system receives an incoming RF wave that is used in 3 different ways. First, it helps transmit through a backscattering mechanism. Our chip essentially reflects the incoming wave and it modulates it in the 2.4 GHz band. Second, it harvests energy to support chip operation without any energy storage or battery. And third, to inexpensively sense the relative position of the chip with respect to the RF wave generator for sensorless motion detection. I will now pass it on to Marco for its demonstration.
Hello, this is Marco. This main idea, leveraging this new test chip, is to reuse a 2-tone RF wave for backscatter communication, harvesting, clock extraction, and position sensing without any additional sensor. The system embeds a novel crossed NMOS free-state charge pump for 2.4 GHz efficient energy harvesting. The measured harvesting system sensitivity is around -20 dBm, as measured at a distance of 5 meters from the RF wave generator shaped by all the surrounding connected silicon chips. The 2-tone PID signal allows to exploit the second-order intermodulation product, equal to 22 MHz, that is 2 times larger than the clock frequency required by the Wi-Fi standard. The output of the charge pump changes linearly with the distance and is exploited for sensorless position and speed detection. Through the system, we are able to measure distance down to 16 cm and 18 km per hour, that is half of Usain Bolt's maximum speed. Now Karim will share further details on the clock extraction from the 2 tones, which eliminates the needs of any on-chip frequency synthesis for lower power.
Compared to prior art, the clock extractor doesn't require any additional power-hungry bandpass filter, injection, locked ring oscillator, phase-locked loop, or oscillator. Interestingly, the extracted clock is inherently resilient against process voltage temperature variation and is Wi-Fi standard compliant, with a jitter down to 93 picosecond with a power consumption of only 75 nanowatt. It is more than 2 orders of magnitude lower than the consumption of phase-locked loops in prior Wi-Fi backscatter transmitters. The backscatter communication allows to reach a distance from the receiver of 10 meters, with hence support indoor application.
The proposed system pushes the power of a Wi-Fi transmitter into the unexplored range of power consumption below 1 microwatt. Such extremely low level of power allows aggressive miniaturization of the energy source for very small, essentially millimeter scale, lower cost, so deep sub-dollar, and ultimately ubiquitous connectivity with existing wireless infrastructure. Sensorless motion sensing paves the way for always-on monitoring of assets and purely harvested location tracking while reducing power by more than 100 times compared to conventional battery-powered devices such as the popular AirTags. Thank you for watching. Feel free to explore more in our Green IC website.